Okay. Okay, so we're again going to do logarithmic functions as inverses. Okay? So we're going to start back with some functions that you guys are familiar with, which is f of x equals x squared. And remember, this is just the negative one, just means the inverse. The inverse of x equals plus or minus the square root of x. Because the inverses are just functions that undo each other. Things that undo each other, like adding and subtracting, undo each other. So if I plug in numbers for x squared, I'm going to plug in 1. When I plug in 1, what do I get? 1. Okay, when I plug in 2, what do I get? 4. When I plug in 3, what do I get? 9. When I plug in 4, what do I get? And when I plug in 5, what do I get? 25. Okay. Now I'm going to do the inverse, which would be the square root of x. Now, do I know off the top of my head the square root of 1, 2, 3, 4? No. Okay, so let's use these numbers because that makes life a lot easier. So what's the square root of 1 now? 1. The square root of 4? 2. The square root of 9? The square root of, now we're doing the inverse function. The square root of 16? And the square root of 25. 5. Okay. Yes, they are the reverse. Okay, which is exactly what an inverse does. The x and y values switch places. So when x becomes y, and my y's become my x's. And that's how all inverse operations or inverse functions will work. Okay, the x and y's are just flipping. Okay, any questions over that? So now let's see what exponents look like and their inverses. So we're going to graph this. I'm going to graph this in blue. So when x is negative 2, if I plug that into here, 2 to the negative 2 is 1/4. So I'm going to graph that right here. Negative 2 and 1/4. Negative 1, I'm at 1/2. So right about here. At 0, when x is 0, 2 to the 0 power is 1. Okay. And then 1, when x is 1, y is 2. And when x is 2, y is 4. So this is my f of x. Any questions over that? I have my asymptote at y equals 0. And let's find the domain of f of x equals 2 to the x. Okay, domain is the x value, so how far left and right can I go? How far left and right am I going? Very good, all real numbers. I can go forever left and right. Then with the range. I do have a limit on my range. Remember, the y values will never hit 0 or go below. So my range has to be y is greater than 0. It cannot equal 0, so don't put a line underneath it, just put it greater than. Any questions over that? Now let's graph the inverse. Since I don't know what undoes 2 to the x power. I guess you could do like the x root because you don't really know what root it is, what exponent that is. Okay. Okay, so we're just going to use our ordered pairs and switch them. So all of these numbers are just now going to become the y. So we have -2, -1, 0, 1, and 2. And then all of these numbers are going to become my x. So 1/4, 1/2, 1, 2, and 4. Any questions over that? Okay, so we're going to graph these points now. So I'm going to go where x is 1/4, which is right about here, and y is -2. I'm going to go where x is 1/2, and y is 1, so right about here, or -1. I'm going to go where x is 1 and y is 0. I'm going to go where x is 2 and y is 1. I'm going to go where x is 4 and y is 2. Okay. And so this now is going to be my graph. I'm going to start here. So this is the inverse of x. Okay. So let's look at the range and the domain. Okay, the domain again is going, left and right. Does it look like there's a limit and how far left I can go? Where do you think it's going to stop at? 0, right? So x is going to have to be greater than 0. Okay. Then what about the range? How far up and down do we think we're going to be able to go? All real numbers. If you notice, the domain was all real numbers, and now the range became all real numbers here. The domain was y has to be greater than 0. I'm sorry, the range right here was the y has to be greater than 0, and now the domain is x has to be greater than 0. So just like you flipped the ordered pairs, the y values became the x, the domain and range flipped as well. Okay? So now you have an asymptote on the y-axis. The what? The range was not all real numbers here, right? The range was y was greater or equal to 0. The domain was all real numbers. Okay. Any questions over that? Okay. If you notice, draw in y equals x. So that's through 0. We're going to create a line like this. So this is y equals x. Okay, your basic form of a linear equation. And if I folded my graph along that line, they would be symmetrical. They'd be on top of each other. Okay, they'd be the exact same thing. And all inverse functions will be like that. Where if you fold your graph along the y equals x, they will match. Okay? That's another fun fact about inverse functions. I know. So exciting. Okay. Let's do the in behavior then of f of x. So we have as x approaches positive infinity, y approaches, let's look back. As x is getting more and more positive, what is y doing? It's getting more and more positive, bigger and bigger, right? X is approaching positive infinity as well. Then we go to the other side. As x approaches, is it going to approach negative infinity? Very good. It's going to approach the 0, the y-axis, where x is 0. So it's going to, as x approaches 0, your y values are going to get smaller and smaller, more negative. So it approaches negative infinity. Okay. Any questions over that? The inverse function, yes. We're looking at the red graph here. Okay. Then the asymptote for the inverse function is x equals 0, because it's on the y-axis, and that's x equals 0. Okay, good, yes. Drum roll, let me hear a drum roll. Oh, come on, you guys. Oh, good, thank you. Logarithm functions are inverses of exponential. They undo each other. So to undo an exponential function, you use a logarithm. To undo a logarithm, you use an exponential. Okay? Details. Yes, wow. How am I so each other? Yes, I'm just making sure you're following along and reading all that I am writing. No, it has an H there. I promise there's an H there. They undo each other. Quiet, please. So the vertex form not of an exponential function, but of a logarithmic function. Ismic, yeah. L-O-G-A-R-I-T-H-M-I-C, logarithmic. Okay, so again, the negative a is going to reflect, just like it did before. You're not going to let me write there, so I have to scroll this down. So negative a reflects. Okay. The log, okay, oh, the a value is still stretching and shrinking. It will be hard to identify a stretch and a shrink on these type of problems because it's a curve. It's not, like our u's could easily be seen. The curve stretching is a little bit harder to see. Yes, you have never seen a logarithm before. In chemistry, you saw it, but they didn't really explain it, right? They said it was the right? You have a 10 to the x power, and they call it the anti-log, I believe. Okay, no. Okay, if the absolute value of a is greater than 1, then it is a stretch, just like always. If it's in between, the absolute value of a is in between 0 and 1, then it's a shrink. H is with the x in parentheses. If there's no parentheses, then there is no h value. Okay? The h value is the opposite, just like always. So negative h moves to the right. Positive h moves left. Okay? And since our asymptotes are always for logarithms are always x equals, this is also going to be your asymptote. Okay, x equals the opposite of h, or negative h. So you still have to change the sign for the asymptote. Yes. It's right, it's hard. No worries. Then positive k is up, and then negative k is down. Just like always. Any questions over that? We're all good? Okay, so you're really not going to graph logarithms too much. You're probably going to talk about their transformations more than anything. And you're just going to want to identify that this is a logarithmic function. Okay? It looks like the exponential function, just turned on its side. Flipped across the y equals x. Okay? So that's basically what you're going to kind of identify. So this is the parent function of log. So this is just f of x equals the log of x. That's what this is graphed. Okay? We're going to want to shift this up 3. Okay? And then reflect it across the x-axis. Okay? So we're going to use our graphing calculators to do this. So turn on your graphing calculators. Hit delete 3 times. Okay, grab it. We hit our tab button. Okay, the log button, you have to hit the blue control, and it's above the 10 to the x. So control, and then this button. Okay? You can also graph these on Desmos if you don't have your graphing calculator at home. Okay, on this, they give you this right here. It's a base, okay? Right now, our base is 10. You don't need to write anything because it assumes it's base 10 unless you tell it something different. Okay, base 10 is the basic log. So you don't need to write anything because it's already in base 10. You want to put x inside that bigger one. And then we're adding 3 outside the parentheses. Because you notice here that the 3 is outside of the parentheses. Because it's a negative log. And we don't use the subtraction sign, we use the minus sign right here. And then you hit enter. We just need to put in the equal sign. Okay, so we're going to graph that. So we want to look for our key points here. So if you notice here, I have my points now is at 1 for x and then 1, 2, 3 for y. That's the point there. Okay? Then you can kind of see at like 9, it's really close to the 2. Okay? So we're going to graph those 2 points. If you notice, this point right here was at 0. This is where you can kind of see the transformation up. So from here, I'm just moving this point up 1, 2, 3. Okay? My asymptote is still at 0, x equals 0. Okay? But instead of going my curve this way, my curve is now going to curve this way because I'm reflecting it. Does that make sense? Well, this one you can, that's a point you can see, right? My first point was at 1, 3 on my graph. 1 and then 3. The next point to see the curve, is it going to be about 9 and close to 2? So about 9 and 2 is right here is where we're going to see. So this is my curve. Oopsie, I went too far down, right? I went to 1 instead of 2. Let's do that again. My point should be about here. Oopsie. Okay. Any questions over that? Yes?
Your first point is just across from wherever the first cross on the x-axis on the other.
It's all going to be different depending on how you're transforming it. So there's not going to be an always. That's why you're going to use your graphing calculator. Okay? Yes?
I do videos.
On YouTube.
Yeah, what we type up.
Okay, the next one. Okay, now our base is changing to 2, and that's okay. The base can change a ton of times. Okay, this is my parent function. This is f of x equals log base 2 of x. Okay. We're going to now transform it by shifting it to the right 2 and down 1. So let's look at our wonderful graphing calculator. So I'm going to hit, yes, the log. This time I want to put in base 2. Then I want x minus 2. And then minus 1. Oopsie, outside of the parentheses, I want to subtract the 1. Okay, so now you guys can see this point right here. Quiet, please. Okay, this point is 1, 2, 3, 4, and 0 now. Because how many did I shift it? Okay, it was at 1, and so then I shifted it here. It's now at 4 and 0.
You
Okay? What's another point? Let's see what 8, because it only goes to 8. I'm at like 1.5 or 1, a little over 1.5. So I'm going to graph those 2 points. Where's my asymptote now?
X equals 2.
Right? My asymptote is right here. Okay? At 2. This again is my asymptote. The opposite. -2, so it's at +2 now. Okay. What?
So you know how there's an 8, 2, location right there?
This is not 8 and 2. This is at 8 and about, I don't know, 1.5. It's on my graph?
Oh, on the graph.
Yes, I haven't graphed this on my paper yet. So I have one here, yes. Like I said, you're going to use your graphing calculator. That crosses the x-axis at about 4. Okay. My new asymptote is right here at 2. Okay. And it's about 8 and 1. So this is my new curve. I can't really make this curve very well. Curve it a little bit better than I did. Please. Any questions over that? Okay, so let's go back to this one because we didn't do our asymptotes in the ranges domain. So the range here is the y values. For this curve, okay, the domain again is the x values, how far left and right. And remember, our x's are getting stuck somewhere. In this case, it's still at 0. I have not translated or transformed it left or right at all. I just translated up and down and reflected it. So my asymptote is still going to be at 0. So my domain is x has to be greater than 0. The range is still all real numbers. Okay, our asymptotes are just at 0. We just have 1. Okay, the end behavior as x approaches positive infinity. Y is approaching. Y is getting more and more negative now, right? It's going down to the reflected. No. X is going to be approaching 0. This, although it looks like it's going to even out, it's still going to keep going negative, just very slowly. Okay? Any questions over that? Yes?
There will be more than one asymptote?
Not for these. We had a bunch of asymptotes when we did rational functions or fractions, but for these you'll just have the one. Okay, and then as x approaches, not negative numbers now because it's not approaching negative, it's approaching 0. Then we have y approaches positive infinity because it's getting higher and higher. Any questions over that? Okay, let's go back. Now to this one. Now since we shifted this to the right 2, it's going to change everything. Okay, the domain, now what is the smallest value for x?
2.
At 2. Because this is my new asymptote. So the domain now has to be x is greater than 2. The range doesn't change in this case because you're just still going up and down forever. So the range is all the numbers. Any questions over that? Okay, and what is the asymptote? Any questions over that? Okay, and what is the end behavior as x approaches positive infinity? Okay, as x gets more and more positive, so is y. Y is going to become more and more positive, more and more bigger. More bigger? That doesn't make sense. Gonna get bigger. And then as x approaches, again, we're stuck at 2 now, not 0. Okay? As x gets closer and closer to 2, y is going to get smaller and smaller. Yes.
Can't that also be read as x goes towards 2 and up? Like, moving that way, you know, from 0, x goes towards 2 and go up. Like,
Yes, but we're going the end behavior, so as it goes closer and closer. So you're going to, like, basically walk on that line. What is the y value doing? Y approaches negative infinity. Right here. That line. Any questions? Yes. That's the inverse. This is not the inverse. This is the parent function, f of x equals log base 2 of x. Okay? And that's the shifting, where you're shifting it up, down, right, and left. If I graph the inverse of this, then yes, I would do it. Any other questions over that? We're all good? Okay. Okay, now we're going to write the equations here. The graph of f of x equals log base 2 of x is stretched by 3 and reflected across the x-axis, then translated up 4 units and to the right 2. Find g of x. So g of x is going to equal your a log base 2 of x minus h plus k. We need to fill in the a, h, and k. So we're going to have g of x equals, the first thing it talks about is being stretched by 3. So the a value is your 3. Then it talks about being reflected across the x-axis, so we need to make that negative. Any questions on how I got that? Then the log, the base doesn't change ever, x. Then it says it's translated 4 units up and right 2 units. So we're going to use the right 2 units next. To the right means this needs to be negative 2. Then we need to talk about the up 4 units, so that's plus 4. Any questions over that? We're all good? Okay, now the graph of g of x is graphed. The graph of g of x is the graph of f of x equals log base 3 of x after a horizontal translation, a stretch in the x-axis, and a vertical translation. Write the equation of g of x. Okay, so I know I've stretched it. I know I've shifted it left and right, and up or down, okay? And I need to determine what that is, okay? The easiest thing to identify is the shift left and right, because that'll move my asymptote, right? Okay, so if I look at this dotted line, Aiden, where is my asymptote then? What is it approaching? 2. So that's this right here. So the h, ooh, that's very interesting. So the h is going to equal 2. Because that's where the asymptote is. Okay? Then, if I'm shifted, so here I started at 0 for x. Okay? We need to find that same point on this graph. Okay? The easiest way to do that is just to look at your curve. From here to here, and then from here to here. Where is my point that I can see within, like, from here to here? Where's a point that is actually easy to identify? 3 and 1, correct? Okay. So how far did that shift it up? I started at 0. Where did I move to? 1, right? Up 1. So the k value is 1 based on this point here. Any questions over that? Okay. Then the stretch is the hardest thing, and I will never give you a stretch on your own, you guys. That's hard to identify. Okay? The stretch is going to be based on here and here. Okay, so find the closest point to this. This is basically the translation of this point. Okay, then you're going to find the next nearest point going up. How far up did I need to go to get there? I have to go up 2 and over 2, right? I only care about the up movement. So that's my A value, is the 2. Okay. In your homework, you're just checking the translation of right and left and up and down. So our equation is g of x equals 2 times the log base 3 of x minus 2 plus 1. Can you guys read that? Probably not. Let me move that. Oh, let's try it again. No, let me just move it. There you go. Any questions over that? We're all good? Yep. The what? It gave it to you. It has to give it to you for you to figure out what base it is. It'll give it to you. Okay. On the back. Okay, we're going to come back to this in a second. We're going to go down to this part. The conversion. Okay. So this is our whole what a logarithm is, okay? Explaining what a logarithm is. Okay. Fix these on yours. So this is 10 to the first equals 10. So the log base 10, it's missing the 10, I think, in yours, equals 1. Everybody rewrite this better. These are my typos I told you about. Okay. Cross this one out and put in this for me. Fix that. Cross whatever's out here and put this in for me. Okay. So exponential form is y equals b to the x. To write this in logarithmic form, it's log base b. So the bases are the same, and that's how you say log base b. B and b are the bases. The y is now the of for the log, and then it equals the x, or the exponent. It equals the exponent. Okay? And that's how you convert an exponential into a logarithmic form. Okay, so now, based on this, now 10 to the first equals 10, so log base 10 of 10 is 1. 10 to the squared equals 100, so log base 10 of 100 equals 2. 10 cubed equals 1,000, so log base 10 of 1,000 equals 3. Now, using that information, I want you guys to write the following order from least to greatest, then explain how you knew where to place each expression. Okay, so in your groups, work together to see what each of these equal. Yes, change it. So what do we think log base 3 of 3 equals? 1. What about log base 3 of 9? What do we think that equals? How about log base 3 of 27? How about log base 3 of 1? And log base 3 of 1 over 9th? Negative 2. So if you look here, I need if we look back up here, 10 to the first equals 10. Notice the two numbers are 10 and 10, and then it equals the exponent. So you're looking for what exponent, or what do I need to raise the base to? So the base 10, 10 to the what power will give me 100. 10 squared will give me 100. So 3 to the what power will give me 3. 1. 3 to the first gives me 3. 3 to the what power gives me 9. 2. 3 to the what power gives me 27. 3. And then 3 to the what power gives me 1. 0. And 3 to the what power gives me 1/9. Negative 2. Okay? So explain how you knew where to place each expression. Not equals 1, equals 3. So for A, I found for A, 3 to the x power gives me 3. And that gave me x equals 1. Because 3 to the first will give me 1. Okay? So my order should be E, then D, then A, then B, then C. Any questions over that? Okay, go on to the next one. No. No calculators. Okay, so Braden, what do you think?
First one, A is 4. B is 1.
B is 1?
I mean, no. I mean, 2.
2.
A is,
C is
log A is 1. So log
base 5. It's log base 5 of 25. That's how you read that.
Base 5 is 25, 2. And log base 2 of 32 is 5. 4 or 5?
It's 5? Yeah. Okay, so my order then would be C, then B or D, whichever you want to put first. Then A, and then E. Okay. Explain. I found the exponents. To get each answer. Okay, I found the exponent need to get each answer. So again, this is the base, and then the of is what I'm trying to find. Okay. Any questions over that? Okay, on the back. I know, there's another page. I passed it out, yeah. We're on page 15 now. Okay, determine if the following arithmetic expressions is sometimes true, always true, or never true. If it is sometimes true, explain the conditions under which it will be true. Explain your reasoning. So again, I'm going to have you guys work in your pairs to come up with these answers. That's fairly weird. Okay, I'm very oh, let's close that. Okay. Whew. Okay, Jaden, what did you get for the first one? Okay, and when is it sometimes true or when is it sometimes not true?
It's true when X is a whole number.
Can we say when X? Okay. Okay, when X is a whole number. Okay, I'll give you that. Okay. Yes, but you could have like 5 over 2, right? So, I'm okay with a whole number. Okay. Okay, or you can say it's going to be negative when X is a fraction. Okay, or is it between 0 and 1? You don't want it to be, yeah. Okay? So that would work too. Next one. Furman. B is greater than 0, log base B of B equals 1. Sometimes, always, or never. Huh? What was your answer? Why not? So did you do, so when we were, it is always true. Right? If the B's, if they're matching, like 8 to the, right, base 8 of 8 is going to equal 1. Base 4 of 4 is going to equal 1, because it's the exponent we're looking for, and if they match, that means it has an exponent of 1. Okay? So this is always true. Okay, Matt, the next one. The log base B of X is undefined if X is a negative number. Not true? Never true? Okay. What'd you get? Always true. Well, let's think about this. Okay. The log base b of x is undefined if x is negative. Okay, x is what it equals, right? So b to the what power is going to give me a negative number. Okay. Do exponents affect the sign of your answer? No. Okay? So this is always true, because for logarithms, we're never going to have a negative base. Okay? The only time you're going to have an exponent, yeah, you won't ever have the b be negative, so then your answer, the x will never be negative. Shh, quiet, please. Mackenzie, what about this one? Log base b of 1 equals 0. Oh, I don't have... Justin. Log base b of 1 equals 0. Yes, always true. Because any number, what's 8 to the 0 power? How about 5 to the 0 power? Okay, so this is always true. Okay, any questions over that? Okay, your homework, you guys, is page 16 and 17. I need to give you guys, I passed out the extra page, because you're missing a page from your notes. You guys need this and this. What in the world?